Welcome to Chapter 3, Section 3, Day 3, I think? Part 3, or Part 2. Part 2. The secant of 2x equals the secant squared of x over 2 minus the secant squared of x. So the secant of 2x, again, we don't have a rule for right now, and we haven't actually developed our cosine rule yet. But let's take a look really quickly down at the bottom of the page and develop our cosine rule. Because if we have the cosine of 2x, that should actually be the cosine of x plus x. And if that's a plus b, that would be the cosine of a times the cosine of b is the same thing as a this time, minus the sine of a times the sine of b, but cosine times itself is actually cosine squared, minus the sine itself is the sine squared. Again, this looks a little bit close to sine squared plus cosine squared equals 1, the Pythagorean rule, but it is actually a little bit different, and again, the subtraction does not, means that it comes out to be something else entirely. But now we have a new cosine rule that we can work with in order to deal with our secant rule here. I'm going to change the left side of this equation the entire time rather than the right. Because the secant of 2x now we can make into 1 over the cosine of 2x. And the cosine of 2x is cosine squared minus sine squared, so 1 over the cosine squared of x minus the sine squared of x is going to equal the secant squared of x over 2 minus the secant squared of x. Sine squared, we could say, is 1 minus the cosine squared. And if we distribute this negative, then we get cosine squared minus a negative cosine squared would be plus, so 2 cosine squared of x minus 1. And if we change the base a little bit here, because I now see my 2 and my minus, if I multiply the top and bottom by the secant squared, we can distribute on the bottom. And remember, cosine times secant is 1, so cosine squared times secant squared is 1 when we distribute. So secant squared of x times 1 is just the secant squared of x over 2 times the cosine squared times the secant squared is just 2 minus, and then the secant squared times 1 is secant squared, and it still equals that same thing it was always supposed to equal. Next part, the sine of 2 phi equals 2 times the cotangent of phi times the sine squared of phi. Again, sine of 2 phi, we've already seen, is 2 times the sine times the cosine. And I'm only going to change the left side of my equation here. I can kind of make this look like fractions if I... And the reason I want to look like fractions is because of that cotangent. Cotangent needs to be cosine over sine. So if I multiply top and bottom by sine, then I can sort of rearrange some of these factors here so that the sine times the other sine So the 2 stays out front. And we can get cosine, or just cosine. And then sine times sine is sine squared. All that is over sine. Remember, we're not adding or subtracting, we're just multiplying, so we can separate this fraction a little bit as we need. And I forgot to say equals 2 times cotangent of phi times sine squared of phi a few times. So we have 2 times the cosine over the sine times the sine squared. And the cosine over the sine is the cotangent. All right, I don't need the equal signs on this side. I just need them in the middle. And again, I didn't change the right side at all. I just made the left side match. Okay, last couple. And I know that the very last one was a little bit difficult to read. The tangent of r equals 1 minus the cosine of 2r over the sine of 2r. So we've already looked at our sine and cosine double angle rules. So we'll just start applying them. Cosine of 2r is cosine squared minus sine squared. Sine of 2r is 2 sine r cosine r. If we distribute our negative here, we get 1 minus, the tangent of r equals all this. 1 minus the cosine squared of r plus the sine squared of r over 2 sine r cosine r. 1 minus the cosine squared could be made into the sine squared. Sine squared plus sine squared is 2 sine squared over 2 sine r cosine r. The 2's will cancel out. This sine can cancel one of those signs. So the tangent equals the sine over the cosine. And the sine over the cosine is the tangent. So the tangent equals itself. All right. Now, there is some weird misprinting here in number 31. Here's what I think what was supposed to happen here. Instead of a weird B and G, I think these were supposed to be parentheses that got mislaid somehow. So the actual problem is the sine squared of theta equals 1/2 times 1 minus the cosine of 2 theta. So you may want to pause for a second and try that problem on your own before we continue. Okay, cosine of 2 theta, we can change. Cosine of 2 theta is the cosine squared of theta minus the sine squared of theta. Again, we can distribute that negative here. So that equals 1/2 times 1 minus the cosine squared plus the sine squared. And again, because that cosine is now negative, we can't actually say cosine squared plus sine squared equals 1 because we have this minus hanging off the front. But we can take the 1 minus cosine squared and turn it into a sine squared. Sine squared plus sine squared is 2 sine squared. And half of 2 means that the sine squared of theta equals itself.